the graduate student work is vital to making scholarship work on campus, and so we want to showcase a few of the international projects, knowing that there are a lot of people that we won't have time to talk about international projects, but we've got 4 really interesting projects that from all over the world. Maame Hagan, a MA candidate in global area studies. Dale Novotny from my own Ag and Applied Economics department. Ryan Anderson, an MS candidate in geography, and Diem Thu Pham, a PhD candidate in zoology and physiology. I'll go ahead and get started with Maame. Okay.
Okay, thank you all for coming. My name is Maame Hagan from the Global and Area Studies Department, and my research focus is on corporate social responsibility in Ghana's emerging oil industry, and it's a field research that I did this past summer. It's being supervised by Dr. Marcus Watson. So I thought it'd be beneficial to first start defining what corporate social responsibility is. And a speech by Kofi Annan, the former UN Secretary General, embodies the idea behind social responsibility. So he says, "Many of you are big investors, employers, and producers in dozens of countries across the world. That power brings with it great opportunities and great responsibilities. We have to choose between a global market driven only by calculations of short-term profit and one which has a human face." So it's basically companies trying to contribute to the communities that they work in, because most of the time these companies, their activities tend to affect the communities that they work in. And my personal motivation for undertaking this study, coming into the Global and Area Studies program, I was very much aware of how countries like Nigeria, Angola, Sudan had been unsuccessful in managing their oil resource, and because of that, they had fallen victim to the resource curse. And many research that has been done on this, on these countries have argued that it's because these countries did not take into consideration the perceptions and the expectations of the stakeholders in the oil industry. So because they did not take into consideration these expectations and perceptions, this is why these countries have fallen victim to the resource curse. So I was very early on interested in doing research on a newly developed oil industry to see if right from jump, if the expectations and perceptions are made known, if it would be a factor in helping to create effective policies and then eventually helping to avoid the resource curse. So Ghana tended to be that ideal case study for me because it just recently discovered oil in 2007 and started drilling in 2010. So that was my motivation for wanting to study Ghana for this research. So based on this information, I developed the following research questions. First, I wanted to find out what the expectations of the stakeholders in Ghana's oil industry were. And these stakeholders include the oil companies, the communities, as well as the government. And secondly, I wanted to find out what the perceptions of these stakeholders were. So how do they perceive each other, and also how do they perceive social responsibility? And related to the second question, I wanted to also find out if our understanding of social responsibility here in the West translates similarly to an industry in a developing country like Ghana. So a little background information on Ghana. It's in Western Sub-Saharan Africa. It's one of the countries that is perceived to be the African model because of its rich history as the first sub-Saharan African country to gain independence. It has a population of about 24.5 million. Its GDP per capita is $1,600, approximately $1,600. And in terms of poverty reduction, only 3% of the population lives below the poverty line. So it has made great strides in reducing poverty. And politically, it's a country that enjoys multi-party democracy. It has enjoyed peaceful political transitions over the past years, with the exception of the 1980s, where it experienced some political instability. And in terms of corruption, the World Bank has noted that it's one of the countries in Africa that has tried to reduce corruption, not prevent it, but reduce it. And the significance of this study lies in the fact that Ghana, it is on the verge of making history. It can either be a follower or a leader when it comes to oil resource management in Africa. The specific study area took place in Cape 3 Points, which is shown with the red star. It's located between Axim and Takoradi. It's one of the few communities in Ghana that has gained both local and international recognition because of the recent oil find. It is a community that has about 500 inhabitants who are predominantly fishermen. 4 of my respondents told me that they were earning about $6,000 prior to oil drilling beginning. And after oil drilling began, only one of the 4 respondents said they were still earning this amount. So many of them have seen a decline in their income since oil drilling began. And the reason for this decline is because many of them have been banned from fishing because it interferes with the oil drilling activities of the companies. So it's a community that is blessed with beautiful beaches that attracts tourists all year round. It also has other natural resources such as cocoa and rubber plantations. Despite all this resource wealth potential, it's a community that lags behind in terms of socioeconomic development and also suffers from social exclusion as well. It has one primary school that services the whole community. It also has no hospital, and there's also a lack of basic human amenities such as pipe-borne water, electricity, and good roads, just to name a few. So the oil companies involved in the area include London-based Tullow Oil, which owns about 35% of the property rights in Ghana. Other companies include US-based Cosmos Energy and US-based Anadarko Petroleum Company, as well as the Ghana National Petroleum Company, which owns about 14% of the total property rights in the country. So the methods that I used in pursuit of the perceptions and expectations of these stakeholders, one method that I leaned towards was interviewing. I did interviews with 7 oil company representatives. I also interviewed 15 members of the community, as well as 1 representative from the Ministry of Energy and 1 from the Environmental Protection Agency, the EPA. I also did a lot of direct observation. I lived in the community and witnessed their day-to-day living conditions, and it kind of shed light on their living conditions and what they said to me during the interviews. So I saw firsthand what they were talking about. And this was done during the month of June. I also used focus groups. I did 1 focus group with 8 fishermen, and I also did another focus group with 5 women. And the reason why I did focus groups was because I wanted to have people with similar statuses in the same group so they could either add to or challenge the views of one another. And this helped me to validate some of the responses that I got from the respondents. And the final method that I used and continue to use is content analysis of literature that has been done on social responsibility, as well as analysis of the disclosure documents of companies and disclosure documents of the government as well. And that's the picture of my tour guide, who was very instrumental in guiding me to people who would be instrumental in my research. So research findings. So one of my questions was to find out what the expectations were from the oil find. And one expectation was maintaining the existing sources of livelihood. Many of the respondents were very comfortable with their sources of livelihood, which comes primarily from fishing and farming. So it's expected that the effects from oil drilling on their sources of livelihood would be very minimal. And a second obvious expectation is the provision of social resources. Since they lack these resources, it's expected that with the oil find, there will be more schools provided to them. They will get access to electricity and pipeline water, among others. And then another one of the expectations from the oil find is transparency when it comes to deals that are made between the government and the oil companies, and also community engagement involving the community in these deals that are made, letting their voices be heard, and just including them in everything that's done between the government and the oil companies. So another one of my research questions was to find out the perceptions of each of the stakeholders. So I wanted to know how the community perceived social responsibility, as well as how they perceived the companies as well. And one perception that came up was that oil companies have unlimited sources of wealth that they're making from the community. Another perception that I gathered from interviewing the community was that oil companies are seen as agents of underdevelopment. So this came up because the introduction of oil companies into the community is associated with a threat on their livelihoods. So oil companies are associated with underdevelopment. And a third perception that I gathered was that even though oil companies are associated with underdevelopment, they're at the same time seen as alternative governments. And this is as a result of the government not being able to provide for their basic amenities over the years. So all attention is shifted to the companies right now to be the new government for them and provide them with the things that they lack. And on the part of oil companies, one perception that I gathered from interviewing some of the representatives was that the communities have a misunderstanding about them and the wealth that they make. So with this perception, they go against the first perception of the community, which is that they have unlimited sources of wealth. And the second perception that I gathered from interviewing the oil company representatives is that even though they do feel responsible for the communities that they work in, they still feel that they cannot assume the developmental role of the government. The most they can do is supplement whatever the government puts in place. With the government, the main theme that was gathered from them was that the role that they see themselves playing right now is to be a mediator between the oil companies and the communities, so that they can avoid conflicts that come about because of the interaction between these two groups. So if you take a country like Nigeria, where the government has not been able to act as a strong mediator between the two groups, it has led to a lot of conflicts between them. And also the government is acting right now as an assuring voice to assure the community members that the benefits from oil drilling will not be may not be enjoyed for many years to come. So patience is very necessary at this time. And all this is being done so that they can avoid conflicts between the stakeholders. So my third research question was to find out how an industry in a developing country like Africa perceives social responsibility, and how it is related to, and how we in the West understand it. So what is the relationship between the two? And a theory that guided my research was one advanced by Archie Carroll in 1991. And according to her, our understanding of social responsibility here in the West can be placed into 4 categories, and the 2 main important ones are economic responsibility and legal responsibility, which is obeying the rules and the laws of the communities that companies work in. So those are the 2 main components that are important in the Western world, and philanthropy is the least important one. However, when I analyzed my perceptions and expectations in relationship to the theory, I realized that no, in a developing industry such as Ghana's oil industry, the understanding of social responsibility lies mainly in the economic responsibility and philanthropy, which is given back to the community. So those were the two main understanding of social responsibility. So a side-by-side comparison, you can see the difference between the 2 understanding of social responsibility. So my recommendations are basically first to strengthen existing legal and regulatory frameworks that exist in Ghana. As of now, the legal framework was formulated in the 80s, so we're in a new era, and this needs to be updated and strengthened. And secondly, community engagement, involving the community in decision making and the deals that are being made, letting their voices be heard. And then finally, Ghana has, because it discovered oil so late, it has all these other models to look up to, so it can be able to prevent the curse by looking up to other models that already exist. And my research was made possible by the following funding sources: the Dick and Lynn Cheney Research Grants, the International Studies Research Internship Excellence Fund, and the L. Bogan Research Excellence Fund. Thank you.
Good afternoon, everyone. I'm Dale Novotny. I'm with the Department of Agricultural and Applied Economics. I work with Roger Kupal as my academic advisor. And so I've got a great project. It's the economics of small farmer fertilizer use around Guatemala's Lake Atitlan region. All right, so Lake Atitlan, it's in the southern portion of Guatemala, which is on the southern end of Mexico. We've already had a presentation on Guatemala, so you guys are already a little bit familiar with the area. If you look a little bit closer there, that's the lake. And if you emphasize that a bit more, you can see that there's about 12 communities surrounding the lake and about 400,000 inhabitants. And a little more description, if it's going to work. There we go. Description of the study location, a little more in detail. And so we have the introduced system of tablones agriculture, which means terraces in English. The lake itself is about 50 square miles surface area, 23 cubic kilometers of water, fresh water in it, so it's a large resource for this area. It's an endorheic lake, which means that there is no outlet. It does not drain into the ocean. Everything that comes into the lake stays in the lake. And there's 2 main ways that people make a living in this area. One's from agriculture, and the other is from tourism, from the people that come to visit the lake. It's very beautiful. It's a big attraction. Okay, so this project gained international attention when in 2008 and 2009 there was large algal blooms across the entire surface of the lake, and so we have Landsat images here, and the parts that are red and orange are the algae blooms, and so they're actually coming up as land cover types. So if you remember, I said before, this is 50 square miles of surface area there, so we're talking about a very large event, and the problem we want to investigate is what's happening to the lake. Why is it changing so much? So part of that problem is the overuse of phosphorus fertilizers. Why use phosphorus in agriculture at all? Well, it's one of the 3 macronutrients beneficial for the growth of all crops, especially in early maturation and seeding. Sources of phosphorus in the lake watershed, 2 major sources. One is from sewage and refuse from these communities, which drains straight into the lake. There's no economically feasible way to get this sewage out of the lake area because it's a large caldera with steep slopes. And the other one, which I'm concerned with, is agriculture, or the phosphorus that drains from these tablone fields into the lake. Another important aspect here is that phosphorus stays in the soil a bit longer than your other nutrients. Nutrients as nitrogen and potassium there, the N and the K. And so the only time that this phosphorus gets into the water is through large rain events, and it all happens at once, and it causes the algae to bloom out of control. Second part of the problem is a policy by the Guatemalan government, the PEF, which is Programa Entrega de Fertilizantes, and in English, that's the delivery program for fertilizer. So this was the main focus of the project first, but as we've gathered more information, we're seeing it doesn't have as much of an effect on fertilizer use as we previously thought. And so the focus is kind of shifting away from the PEF. Some other things under investigation by my project are why phosphorus-heavy fertilizers, what's the apportionment by this program, who gets how much fertilizer, where does it come from, what does it cost the government to provide this service, and what are the concentrations. So we have normal fertilizer bag here that you might find in the US, and your concentrations are going to be listed in order from nitrogen, phosphorus to potassium, so the N, P, and K there. And then there's an actual fertilizer bag I found in Guatemala next to it. And we're testing the hypothesis that small-scale farmers in the Lake Atitlan region are using greater amounts of phosphate fertilizers than is economically optimal, and the PEF has little impact on agricultural production. So how does this fit into the big picture? Well, the individual farmers are using more phosphorus than the plants absorb. That is getting into the lake, causing eutrophication of a specific type of cyanobacteria called Lingba robusta, which is rare in the rest of the world, but not in this area. And community level effects are tourism is decreasing because the lake is no longer as beautiful, so less people are visiting it, and it's affecting both those major types of income. Here's a little diagram of the simplified grader project. There's a lot more things at work here than what I'm working on specifically. So we want to do an overall analysis of the watershed. The UW Hydrology Department is working on that. Community and urban planning and the water treatment from the raw sewage is another aspect of the project that World Bank is interested in. And the one I'm working on is just the agricultural production and consumption side of things. Sources of data for the project. Mostly depended on research trips. So we took one last year, and we're going to have another research trip to Guatemala this summer. We have 2 partner universities, University del Valle in Guatemala City with an extension college in Sololá, and Sololá is the province that surrounds the lake. And a second university is giving us information in San Carlos. Another good aspect of these partner universities, one is public, San Carlos, and one is private, UVG. So we have 2 different perspectives there. Things that we've learned from the trips, amount of phosphorus fertilizer used. On the first trip, we found a few statistics for use. Costs of production, sources of income, and types and quantity of crops grown. And another thing we found out is that there's a lot of subsistence versus export production going on. So we have milpa versus export crops such as broccoli that are destined for the US. And milpa is your traditional system of growing corn, beans, and squash together. And so we found that there's actually a cultural component there, not just what we'd call calculative reason, where you base everything on economics. The milpa gets less economic return for the people, but even still, they devote much of their land to milpa production. It's a form of security for the family, food security. Other data gathered from online research and in-country contacts, of course, is also important. Okay, findings from our first research trip continued. The description of the PEF, the online documents that I have and that are available to anyone is a little bit different than what's actually going on in the country. And this underscores the significance and the contribution of actually going global and studying abroad. I wouldn't have been able to find out these differences had it not been for the trip, so really appreciative of that experience. The short-term contracts that these buyers have, companies that export crops from Guatemala will deal seasonal contracts with the small share farmers in this region just for a season, and they will also provide them with inputs, tools, and fertilizer in some cases. And so that's another dynamic that we learned about through the trips. We also found the names of the companies that supply fertilizer to the PEF and to people, and the names of companies that buy or export crops from farmers. Market data prices, that's also good for production functions, I'll get into later. Units of measurement were a little bit tricky. People produce in units of a cuerda, and a cuerda may be anywhere from 20 by 20 meters to 90 by 90 meters, depending on the area, so we have to pay attention to who has a cuerda where. And then farmer organization, we learned a lot about that from these trips. There's co-ops, and then there's actually a lack of organization that resulted from the Civil War. All right, so what we have here is the regression of the marginal benefit of phosphorus fertilizer use over time. And I know that's an earful, so I'm just going to go through and explain a little bit better here. So on our vertical axis, we have productivity resulting from phosphorus fertilizer use. On the horizontal axis, we have time. So as you start out from zero, you use a little bit of fertilizer, your productivity of your crops is going to go up. So you produce more crops that input. As you get more and more fertilizer in that system, the marginal benefit kind of levels out, gets to a plateau. And if you keep adding fertilizer past that point, you're actually going to decrease the productivity of protein in the crops. So, too much of this input is not a good thing. Wait a minute. Okay, and our hypothesis follows that current use is somewhere in the plateau area. So, not quite the economically optimal area, but also not in the decline. This a little bit of overuse is also what contributes to the mass eutrophication events. So we need to know those current statistics, which we found some of on our first trip. And then those optimal levels of phosphorus are going to be dependent on soil nutrient budgets. So given the type of soil in the area, which is mostly volcanic, and given the types of crops that are grown, what amount can be uptaken by these crops versus what's left in the soil to be used as runoff into the lake. Preliminary modeling, I'm not going to put up a lot of the modeling up here, just basically what it's about. If anyone wants to see the model steps in a little more detail, I can stick around and answer questions about that. But the main aim is to maximize small share farmers' total revenue through profit maximizing. TR, total revenue, will be determined algebraically against demand equations, and these demand equations are going to be dependent on the number of people in the household, what exactly they demand out of the crops. Model considerations, what are the price of goods sold or value of goods produced for consumption? And then prices received for off-farm goods produced, so people could either regulate their labor hours on-farm or off-farm, and what's the difference between returns there. Quantity of off-farm and on-farm goods produced are going to result from the amount of labor devoted to each of those. And there will be two production function aspects into the greater model. Crop production function, where the inputs of interest we're looking at are L, labor, and phosphorus. Obviously, there's going to be more inputs and factors into what goes into making a crop than that, but those are the two of interest for our project. And then the off-farm production function, off-farm production function is going to be just a function of labor. Model constraints that will be used in the algebraic modeling. One is the subsistence or the survival constraint, where you have to consume a certain amount of calories a day or a week to stay alive. And so there's a set level of consumption that must be met regardless of production goals. Labor availability must be less or equal to the maximum hours each person in a family or a household is willing to work per day, multiplied by the number of laborers available. So we were finding anything from a household of 3 to a household of 12, so that's going to vary a lot. And then the maximum beneficial phosphorus. So that's going to be less than or equal to a set level found again by that soil nutrient budget. What can be uptaken by these crops? What will they actually use versus what is wasted when it's put into the soil? And then budgetary constraints. Wages received for off-farm labor. So it's the opportunity cost of actually going out and finding a job outside of the farms as opposed to working on the farms for returns. Return for your on-farm labor, and that can be in the form of either selling those products at market or in the form of using those crops for subsistence. And then the total prices of phosphorus fertilizer used in production. So if they're using more phosphorus than is beneficial to them, that's wasted money, that's more phosphorus going to the lake, and that's less food on the table. All right, and then wrapping up here, a real look at the cyanobacteria blooms. This is a photo I took of the lake in wide angle. So we got the opportunity to go out on a boat with a couple of doctors that work in the area and do some water quality sampling. So you can see the actual, they're pulling up jars of water through a filter there and then putting them into jars and testing, and that's what the actual algae looks like. And we are finding this at different depths and different locations all over the lake, so it's not just in one area. But if you look at the picture a little closer here, ooh, there we are. That area there, that's the big bloom area. So if you can imagine that over the entire surface of this lake, that was the large bloom events that occurred in 2008 and 2009. But this was just shot last summer. So there is still some problems with the eutrophication, but it tends to happen in large events all at once, not slowly and steadily. All right, and that's about all I have. Our project funding, this Druk Fund again, from the Senator from Guatemala, Department of Agricultural and Applied Economics graduate student travel grants, and 2 Dick and Lynn Cheney study abroad grants. And I also want to extend a special thanks to our partner universities down in Guatemala. They're really helping us with data and with their collaboration, so a special thanks to them. And that's all I got. Thank you.
All right, hello everybody. Thanks for sticking around. My name is Ryan, and I work with Steve Prager in the Department of Geography. And today I'm going to be talking about soil conservation, agricultural management, and the Blue Nile Basin of Ethiopia. Okay, so the really broad issue that this research is trying to address is food security in Ethiopia. Ethiopia, as well as many other countries, is facing issues such as population increases, various environmental pressures, changes in climate. And so there's a lot of research that's beginning to crop up to try and understand how various systems are going to be able to cope with these types of changes. How do you bolster resilience against these kinds of changes? And this research is one aspect of that. So there's more interest being geared towards these watershed scale management strategies that focus more on local environmental characteristics. And so these agroecosystems are very common in Ethiopia. They support 80% of the population. And one really important thing to note about these are that they are almost entirely rain-fed. There's very little irrigation in Africa, in Ethiopia specifically. And a lot of agriculture occurs in these systems, which are often various crop types mixed with grazing. And so since they're rain-fed, they're very closely tied with different rainfall regimes, with the quantity of precipitation, and that's kind of one of the things you think about with global climate change models. With changing rainfall regimes, you think about the quantity of rainfall, which can obviously lead to issues such as droughts, floods, but there's also the timing issue, so the variability of that rainfall. And so if really intense rainfall comes, creates issues such as soil erosion. If you have poorly timed rainfall events, perhaps before crops have really rooted and been able to hold the soil, or late in the season, then that can also cause issues such as soil erosion. And so I'm discussing soil erosion because it's really important. It's one of the metrics of watershed health that we're looking at in this research. And it's because all terrestrial crops depend on a healthy soil base. With soil erosion, you have issues such as loss of soil water, loss of overall fertility, loss of arable land. It really affects agricultural productivity in general. And Ethiopia is known for having really bad issues with soil erosion. So management strategies are kind of geared towards how do you minimize erosion and how do you maximize agricultural productivity or efficiency. So it's best to understand what that relationship between the management and the landscape is, because management decisions are affecting productivity, they're affecting soil erosion, and so we have to understand how these decisions are actually impacting the landscape, impacting the productivity of the systems. So the purpose of my research is to simulate different types of management scenarios, management strategies, and these zonal strategies, which I'll talk about in a little bit, to measure the effect of the structure of the landscape or the spatial arrangement of land use practices. So here's my study area. It's in the central highlands of Ethiopia. It's a very small sub-watershed. It's only about 2 square kilometers in size. It's an agroecosystem, as I mentioned earlier, and it has all sorts of mixed crop types. It has livestock, cows, goats. It has a ton of things going on in this very small area. So it's a very small community. I had the opportunity to go out there a few summers ago, and I visited for 6 weeks. We conducted smallholder interviews, rapid ecological assessments of land plots, and we measured plot boundaries and other various characteristics of the landscape. Okay, so this kind of gets into the methodology that we're doing here. Again, we're trying to computationally simulate different management scenarios. And so it's been out in the research that it might be a good idea to split the watershed into different zones. And so that's what you see here, this dark blue to the tan. This is splitting the watershed into 3 zones. Just essentially, you can kind of think of it based on elevation. So you have the upper, the middle, and your lower slopes here. And the idea is that different land use practices are more appropriate for specific zones of the watershed than other land use practices. So in the upper watershed, where you're going to have perhaps steep slopes, you have a very large downstream contributing area. So if you lose soil up there, it flows throughout the system. It's deposited in various places. So you might place natural vegetation or trees in this upper watershed to minimize this downstream influence. In the middle watershed here, you might place things like corn, crops that have decent soil retention, water retention. And then in the lower watershed, where it's much flatter, you have activities such as grazing. There's not much downstream influence. Activities such as fallow, so that you're not affecting downstream environments. So that's the theory. The idea that we're going to do is we want to actually quantify this because it's been put out there, and we actually want to understand how it reacts with the landscape. So the way we do that is by modeling soil erosion and deposition. And we use the USPED model here. You don't have to worry about all these parameters. They basically just relate to the topography, erosivity of the landscape. What we're really interested in my research is specifically the C factor here. And so the C factor relates directly to the land use type. It's just based on empirical data, and it essentially just quantifies different land use types because grazing is going to have a much different influence on soil erosion than something like a tree crop. So back to this idea of the zones. You can think of this as one management scenario where we're placing the land use practices based on this logical allocation, these zones within the watershed. But we wanted to do it with multiple management scenarios. So this one was based, again, on elevation, and it's called the Topographic Position Index, or TPI. So there's 3 other scenarios that we also want to take a look at. The second one being the TPI with the riparian protected. This is essentially the same thing, just with, in the simulation, we're essentially just placing natural vegetation in areas of concentrated flow. So the locations where water is most likely to flow through the system, we're protecting the riparian areas by putting natural vegetation in those locations. The third is based on slope. So it's just the intensity of slope measured in degrees. Again, so in high slope areas, you want practices such as like trees and natural vegetation that hold the soil really well because there's more potential for soil loss there. In the flatter locations, you're going to have activities such as grazing. And then the final is this upstream contributing area. It's also called the flow. It's basically just, as I mentioned just a little bit ago, it's the likelihood of water flowing through any given point within the watershed and how much water is going to be flowing in that location. And so we're taking these land use practices and we're moving them around on the landscape into their appropriate zones. So again, trees into high slope, high flow, upper slopes, and then grazing into the flat areas, the lower elevation areas. So we do that and we run that USPED model on there to calculate soil transport, erosion and deposition. And we basically simulate that landscape and we do it 1,000 times. And then we calculate soil transport 1,000 times. And you can see the model kind of stabilizes out and we get this measurement of soil transport for that system. And so this is just one of the scenarios here. Now we can look at all these different scenarios against each other, and I think if you're not familiar with this, the box and whiskers graph here, just focus on the red lines there. That's basically just the average soil transport for each of these management scenarios. One very interesting thing to note from these findings is that the actual scenario, or just like the current configuration of the watershed, outperformed many of these proposed management scenarios that are kind of based on these logical ideas. And so I think that says something about the local knowledge in the area, people working these areas for generations and generations, kind of understanding how inputs drive the system and how different things affect productivity and erosion. That being said, there is probably still some improvement to be had given this flow scenario that we looked at, given the model. So here's the results just kind of displayed in a spatial representation. And what you're looking at in blue are locations of soil deposition. In red, you're looking at soil erosion. And the idea here is just to note that erosion and deposition is happening essentially in the same locations in all of these management scenarios. So something like this is really useful for targeted management programs. So identifying hotspots of erosion or deposition, and rather than using a blanketed management approach, you can target these specific problem areas. So some conclusions, some future research here. This research is really useful for informing management decisions. Again, identifying these hotspots, targeted management programs. For future research, it might be useful to do like a computational optimization research, which we're just moving these land uses around based on kind of what makes sense, what's been proposed in the research, or what makes sense into these zones. It could be useful to actually run an optimization to find what's the optimal configuration of the landscape. And then finally is what are the multi-scale implications? What if you took this research and we're just in a very small 2 square kilometer watershed? What if you scale that up to the entire Blue Nile Basin? Or if you applied this research into a completely different part of the world, do you see similar results? And that would be a great avenue for future research. So with that, I'd like to thank the International Water Management Institute and the Department of Geography at the University of Wyoming for supporting my fieldwork and my research. Thank you.
Hi, so my name is Yim Pham. I am a graduate student at the Department of Zoology and Physiology. Over the next few minutes, I'm going to take you to a scientific journey that my advisor, Dr. Harold Berkman, and I have been pursuing for the last 4 years. So first, I'm going to take you to the history of dioxin issues in Vietnam. Then I'll share with you the objective and method of these studies. And at the end, I'll show you the results and also the recommendations based on these studies. It's not working. Oh yes, thank you. Okay, so during the Vietnam War, especially from 1961 to 1971, the U.S. military executed the Operation Range Hand missions. The purpose of these missions is to expose the transportations of northern Vietnamese soldiers by spraying herbicides at approximately 10% of former southern Vietnam. So this is the map showing the spray areas in southern Vietnam from 1965 to 1971, with the red color in the map indicates the areas where herbicide was sprayed. So there were many herbicides used during these missions. However, a great amount of 12 million gallons was Agent Orange. So the name Agent Orange came from the orange band painted along the sides of these 55-gallon drums, as shown in the picture. Agent Orange is a chemical mixture of 2,4-D and 2,4,5-T. This chemical mixture, however, was contaminated with a toxic compound known as 2,3,7,8 tetrachlorodibenzyl P-dioxin. So from now on, I will refer to this chemical compound as TCDD or dioxins. So the bottom left corner here is the chemical structure of TCDD. So this is the illustrations that I made to show the Agent Orange or dioxin deposition and mobility. So in this picture, we have Agent Orange is sprayed from the airplane to defoliate the forest. We also gonna have the drums that contain herbicides. So these drums may leak and cause dioxin spillage in the areas. And so when dioxin is deposited into the soils through rain, it will be washed into the ponds and lakes located close to these areas. And aquatic species or animals that are consuming food from these contaminated ponds and lakes will also be exposed to dioxin. And human, as the top level of the food chain, we also exposure to dioxin through mainly dietary consumptions. So recent studies have shown that the spillage areas are the main concerns because there are still dioxin contaminations happened, whereas dioxin in the spray areas will more likely be degraded by exposure to UV light. So this is the map have identified 8 dioxin-contaminated sites in Vietnam, and these the identifications was studies by the Vietnamese Ministry of Natural Resources and Environment in collaboration with Hatfield consultant firms in Canada. And so the two areas in my studies are circled in red. They are Da Nang Air Base and the Binh Hoa Air Base. These areas are associated with the spillage of Agent Orange in the depots, and they are referring as hotspot. So this is the picture showing the damage and leaking of Agent Orange drums in the Da Nang airfield in 1971. And so this is the graph comparing the human average TCDD and TEQ concentrations in part per trillion at several locations. And the TEQ here is stand for total toxic equivalent. And the reason why we use this value is because TCDD is a member of a group of chemicals known as dioxins. So the vertical axis here is the average human TCDD and TEQ concentrations in part per trillion. The red dashed line in here is the safety level of 30 part per trillion established by the World Health Organizations. And so we have the US generations, right here, US general populations. We have the Hanoi, this is the capital of Vietnam, and this is the areas where it would not spray with herbicide during the Vietnam War. We also have the Da Nang and Binh Hoa Air Base. These areas are former US air base. And so residents living in these areas exceeded the safety level established by World Health Organizations. We have the Russia study here. This is the locations of the chemical plant. Cefaso, Italy, this is where explosions of chemical plants lead to dioxin contaminations in Italy. And we have Michigan. This is the locations where Dow Chemical Plant is located. And Dow Chemical Plant is one of the big manufacturers that producing herbicide during the Vietnam War. And notice that in the Da Nang and Binh Hoa studies, these values was measured 38 to 39 years after the Vietnam War. So that means that there are still contaminations occur in Vietnam. And so once dioxin is in the body, it could cause various diseases. So based on the studies conducted by the Institute of Medicine, a part of National Academy of Science, the U.S. Department of Veterans Affairs have listed approximately 14 diseases related to Agent Orange or dioxin exposure. Few examples of these would be prostate cancer, respiratory cancers, and type 2 diabetes. And even more worrisome, parental dioxin exposure could also increase the risk of developing birth defects, specifically spina bifida, in their newborns. And not only the U.S. veterans affected by Agent Orange exposure, we also have the Vietnamese residents. So the Vietnam Associations of Victims of Agent Orange estimated approximately 3 million Vietnamese have serious health problems due to Agent Orange and dioxin exposure. Can you please play the video? There's no link for it. Okay, so the slide I have here is supposed to be for videos that show in the orphanage in the 2U hospital. And this, the children in this orphanage were abandoned by their parents because of their health problems. And they have become the symbol of the Vietnam War. So in 2005, the Vietnamese Ministry of Foreign Affairs have estimated approximately 150 disabled children were due to Agent Orange exposure. And in 2010, the Vietnamese government has estimated approximately 500,000 children was born with birth defects due to Agent Orange exposure. So the objective for my studies is to evaluate the demographic, lifestyle, and dietary risk factors associating to increasing dioxin exposure in residents living on or near dioxin-contaminated sites. And so with the funding from various departments from the University of Wyoming, I went back to Vietnam, established the connection with key people from Vietnamese Ministry of Natural Resources and Environment. I was invited to their workshops for birth defects preventions and also for dioxin cleanup. And then I also was invited to to participate in their dioxin reassessments for the contaminations. And in 2010, with their permissions, I went to Canada to help with the Hatfield Consultants, who is the collaborator for this project, to translate the surveys that they collected in Binh Hoa and Da Nang Air Base translate them from Vietnamese into English and also coding them into the computer. And then I used, within emissions, I used these data and ran statistical analysis. So the main statistical analysis I use for my studies is a multiple linear regressions. So this graph here is showing the results for my statistical analysis. So the left column right here is the result for the Da Nang studies, and this one right here is for results related to Binh Hoa studies. So any risk factors that listed in here that are above the dashed line means that they have a positive association with blood dioxin concentrations, and any values that below the dashed lines means that they have a negative association with blood dioxin concentrations. And so an example for this risk factor, harvesting lotus from Da Nang Airport, have been, from the studies that I've ran, it's been to show the increasing dioxin exposure in residents living on or near dioxin-contaminated sites. And so through our analysis, the only risk factors we have found that have a negative associations with blood dioxin concentrations is eating birds, and eating birds here is excluding the eating ducks. And so based on the study that I have, we give out several recommendations. For an example, activities such as swimming, collecting, harvesting, or consuming species collected from contaminated ponds and lakes in hotspots should be banned. Additionally, there should be an educational public program in order to educate residents living in these areas which risk factors would increase their chance of exposing to dioxins. For example, burning trash away at home would increasing their chances of exposing to dioxins. And also we need to have a follow-up risk assessment to study in more detail what risk factor that would contribute to dioxin exposure in addition to what we've found. And so with that, I would like to conclude my talk, and I would like to thank you, these various departments who funded the projects, and thank you for your time.
Would the students come up here and we'll start the question and answer.
I have a question regarding the milpa. With corn, bean, and squash, how do they complement one another to contribute to soil health? Legumes as nitrogen fixers, for instance. And does that necessitate less phosphorus input than cash crops?
You nailed the bean part of that. The legumes input nitrogen naturally into the system. The corn stalk provides a growing medium for the beans and the squash provides ground cover and less evapotranspiration for soil, so less water is lost from the system. And the second part of that question, the answer is yes, less phosphorus is used on the milpa. And a point that I forgot to mention was the milpa crops are grown one per year, so it's grown all year round, just for one harvest rotation, and a lot of them are not irrigated, whereas the export crops, there can be up to 4 growing seasons per year, and they are heavily irrigated, heavily fertilized.
Great. I want to thank all you guys for your presentations. I think it's really interesting. My question is, we have the tendency to do research and then do nothing with it. So could you guys explain what you're actually doing and how some of your findings are going to possibly be implemented in the areas where you've conducted the studies?
Well, for me, I intend on making my findings available to the government of Ghana, as well as people who are responsible for the community, so that they can kind of see some of the recommendations that I have in order to help the communities and also make their what their expectations are, make them known, and this will go a long way to help them. So that's what I will be doing with my research.
For the work that I've done, my advisor's been very active in Ethiopia. In fact, he goes back there multiple times a year and works very closely with the International Water Management Institute, who is on the ground with the community that we worked with. And another great thing about the field work that we collected while we were out there is that it's branched out into 3 or 4 different projects. And so there's pretty good communication between the researchers here and the folks in Ethiopia who are doing the management and the community itself.
As for my research, I work closely with the Vietnamese Ministry of Environmental and Natural Resources. So the results I have here, I reported with them. And in fact, there are actually educational programs going on at these dioxin contaminated sites. With the picture I show on the slide, some of those pictures actually from the handout that they give for the residents living on or near these sites.
One of the outcomes from my project hopefully will be a working paper, a shorter published working paper, and we'll use that model I was discussing. We'll actually give recommendations to the farmers in that region on the amount of phosphorus to use and the amount of labor that they, based on their decisions, should allocate to each, either off-farm labor or on-farm labor, and the returns they could expect to see from those.
Ms. Hagan, you talked about the focus groups that you did. You said you had a focus group of women and a focus group of fishermen. I was just wondering why you chose a focus group specifically on with women and not kind of mixed group.
Well, I felt that many of my respondents from the interviews were men, so I wanted to also give the women some opportunity to also express their view and to see how the oil drilling was affecting them as well. So that was why I also did a focus group with the women as well. So I didn't just want to focus on the men in the community.
Yep. Could you explain why productivity falls off when you use excess phosphate? Is it due to poor crop yields, or is it because of just the cost? And a second quick question, how do you clean up dioxin?
Well, on the marginal benefit for the phosphorus there's only a certain amount that a crop will absorb and turn into productivity. So if I add 1 bag of fertilizer per querda, my productivity is going to go through the roof. If I add 2 bags, it's still going to keep increasing. If I add 5 bags, my return is going to level off because it's just not absorbing that phosphorus. Then what was the second part of that?
Cleaning up dioxin.
Oh, okay. One more thing on the phosphorus.
So why does it go down? Why does it drop off?
Oh, why does it drop off?
Yeah,
Okay, yeah. Because it stops absorbing.
Or is it yield?
It's both. So the cost is going to be the same from bag to bag, but the yield you're going to receive is less, and it'll actually decrease after so many because you're poisoning the soil.
Okay, so as for my part, for dioxin cleanup, there actually have 2 proposed way of cleaning up dioxins. One is through the enzymes that breaking down dioxins, but then the efficiency is not too high. So the U.S. EPA and also the Vietnamese government did not choose to go with that selections. Instead, they go through the Thermal Institute, means that they gather all of the dioxin contaminated soils and then they burned them up in order to break down the dioxins and degrading them. And so that's the method that they use, in fact, for cleaning dioxin at the Da Nang Air Base. Although we have many others dioxin contaminated sites, but the costs for cleaning these up are really high. So what the Vietnamese government is doing right now is using the landfill in order to prevent the spreading of dioxins in the environment.
Is it Novotny? Yeah. My question's for you. In terms of perception about phosphorus, how does the community perceive it? And also, secondly, second question, or do they perceive it like it increases, the amount of phosphorus increases yield, or do they know that there's a decrease? And the second question is, if there's increased fish kill from the eutrophication or oxygen depletion, does that move caloric intake into things that require phosphorus? And if so, then how does the cyclical effects of the caloric depletion from the lake, if they're using fish as a food source, lead to the increase in phosphorus?
Well, I'll start with the fish issue first because I don't know a whole lot about that. That's more your biological side of things. The general ecology of the lake has been messed with significantly by the government there. They've introduced black bass as sport fishing, several varieties of carp to address the eutrophication with the algae, to try and eat the algae. And it's been a real ecological Armageddon down there. The black bass, it's a very deep lake, and so instead of being able to sport fish the black bass, they just live at about 900 feet below the surface. And so we don't even see them, and they've eaten all the other fish. And then the carp didn't really work out either. They just tend to stay low. Perceptions of phosphorus amongst the villages there. This was actually the other part that I lost here, that question. So people realize that fertilizer as an agricultural input is beneficial and it increases productivity. But to what extent, that's where we're trying to put in some new information there. That there is a level at which you stop seeing good marginal returns and it starts to actually decrease or level off, and then you're just wasting money on fertilizer. So they perceive phosphorus or phosphate fertilizers as beneficial, but to what point we just don't know.
Okay, and now to kind of follow up, so do they eat a lot of fish, I guess, in the communities? Is that one of their, not really?
I'm going to direct that one to Roger. He has
No,
more
they
experience in the region.
They don't know.
They don't? All right.
A little bit, but not much.
Yeah, this is in relation to the presentation about dioxins. You said that you recommended against, interacting with contaminated water sources, in that, you can't harvest plants or you can't, use animals or swim in it for that matter. So do you have any projections on how long it is until these contaminations will be resolved?
This is really, I'm not sure if I have a definite answer, because dioxin contamination has happened since 1971 and is still happening now, and there's still dioxin contaminations happens. So it's going to happen as long as it's sitting there. If there is no effort in cleaning up or to confine or to put those dioxin contaminated soils in the landfill, then there's still going to be contaminations happens. So we need to have an effort to clean that up. So I don't have a fixed answer to when the issue will be stopped.
So for Ryan, you talked about having to change vegetation in certain areas. Did you have any sort of study on how that affects the wildlife? If there's a negative effect, or if they just kind of follow the...
Yeah, one of the interesting things about being in Ethiopia is that no matter where we went, really, the landscape was so modified by humans that there's actually very minimal wildlife in the area. The wildlife that is there is viewed as pests, and it's coming in and eating crops and that sort of thing. But these systems are so heavily modified that every inch of the landscape is being used. They're farming on these ridiculously steep slopes and all these sorts of areas that there's not much wildlife, and I haven't really heard anything about how that might,
This one's also for Mr. Anderson. How much does the soil erosion, how much does the land use describe the variability of soil erosion? And how much, are there other factors that might have equitable sort of effects on the soil erosion?
Yeah, so I actually did this as a form of validating the model and kind of transitioning the system entirely from fallow lands, which is really bad for erosion. You have a lot of soil transport, and kind of bumping it up 10% forested area until you eventually ran it to 100% forested. And the differences were very significant. And you kind of get a curve like this where soil transport drops off almost entirely, not entirely, but you have significant reductions in soil erosion by transitioning the system into a more forested area.
Hi, I have a quick question about the dioxin again. And is there a foreseeable timeline where it will naturally degrade on its own, or what's its natural life cycle with or without intervention from humans? And then also another question from Maame I can ask, if you want to respond to that one first, or...
Okay, so I remember the first part of your questions is what is the natural cycle for degrading dioxins? So there's a studies relating to dioxins degrading. So what the study found is that when dioxins is underneath the soil surface, they would predicting that the dioxin contamination could last up to 100 years. So if dioxins were able to expose the UV lights, then it would be breakdown. Yeah. And I'm sorry, I don't remember the second part of your question.
Oh,
Could
the
you
second
repeat?
part was for Maame.
Okay.
So Maame, I don't know if this is necessarily within the scope of your research, but have you found specific strategies implemented either in Ghana or Nigeria where you can contrast positive or negative strategies used by either national or international oil companies that have positively affected communities and what those might be, or if you've seen some that actually that are not positive?
Well, one thing that I found out was that some countries have decided, some oil industries have decided to nationalize their oil industry and to prevent private investors from coming in. And what happened in these countries was that they did not have the technical skills and the technical know-how to manage their oil industry before privatizing it. So there are suggestions that Ghana should privatize its oil industry just so to nationalize, sorry, I keep using them, to nationalize its oil industry. So, so right now, nationalization is on the agenda of the government, and it's been seen in other countries as not being a successful policy move. So that's one thing that I've read in the literature about other countries. So that's a negative policy move that many countries are trying to.
My question is, some of you have done just kind of a case study, and others of you have kind of ongoing work. So I'm curious about what you would do differently, or what would you do next? Maybe that's a better way of saying. What would be the next step to kind of add to the significance, kind of following up on Garrett's question?
For my project, aside from the working paper, I'd like to see that actually implemented. An on-the-ground team in Solila province actually takes around the findings that we got and talks to the farmers, gives them a little bit of advice. As at the moment, the only agricultural production advice they're receiving is from the short-term contract buyers, and those contracts are focused on short-term gains and returns, and it's usually not very optimal for the long-term strategy of the farmers or for their food security. So I'd like to see those results brought actually to the place that we've been working in. Also, a McNair scholarship would be nice. I'd do another year of it, just go down there and.
For me, I'd like to see the community expectations come to life because for many years they've been neglected so much. So I'd like that through my research and making the expectations known, it would help to kind of lessen their social and economic issues that they're facing. So that would be a really good thing that if it came out of my research, I'd be very happy about.
So I mentioned this a little bit in my presentation, but for my work, it'd be really incredible to see it scaled up to a much larger region because, there's issues with working at that kind of scale. And what does it really matter if you're working, if it's very, very local and you can't really, repeat a process like that for every small area. But one of the problems, one of the challenges is, we're talking about reconfiguring the landscape, and that affects people's lives. And one of the main purposes of doing the research, I guess, was to, these strategies are actually being, put out there, and people are saying that it'd be beneficial, and it's turning out that's not actually the case. But I guess what I'm trying to say is it'd be interesting to see like a real life scenario, perhaps a new watershed or something like that, where we kind of designed with these strategies in mind to minimize erosion.
As for my studies, I'm on my next step right now for doing the next work. So the research that I just showed is for my master work, and I'm doing my PhD proposing work right now. And so so in 2012, Dr. Skinner from the Washington State University published studies that dioxin exposure could cause effects in multiple generations, and that was in mouse studies. So for my next step, I wanted to investigate whether that would happen in human also. And my target population is in Vietnamese veterans, and I wanted to see if there is the changes in gene expressions across multiple generations. And that's is for my studies, my up studies.
I'm extremely interested. Your presentations were terrific. I'm really impressed. I really am. But I have a question for for Ms. Diem. And it seems to me that you're accumulating a tremendous amount of information that's a tremendous indictment of the American war. What contributions has the United States made towards solving the problem, cleaning up the sites, and helping with the tremendous needs of the children who have been disabled by this?
Okay, so right after the Vietnam War, the U.S. government did not do a lot of work, but since 2008, the U.S. government has funded a lot of money in order to understanding dioxin contaminations and also support for people affected by Agent Orange exposure. For an example, the U.S. government in 2008 funded 48 million in order to clean up dioxin contamination in Da Nang Air Base. A portions of that money also came to the Vietnam veterans who were affected during the war. So they do make an effort, and there's a lot of effort happening right now, but of course we need a lot more in order to clean up others also.
Last one here.
I was wondering if you would all like to comment on to what extent being able to study abroad has helped to sort of better inform your studies and your general worldviews, as opposed to just learning the stuff like by reading about it or in a classroom. And furthermore, how you would like to encourage other students to participate in doing studies abroad similarly.
Because my research locations is in Vietnam, so the ability of going back to Vietnam and do the studies is very important for me to actually collect the data, first thing. And the second thing is that when I go back to Vietnam and studies, I learn a lot about the connections, like the people skill that I would not learn it in class, and that's, I think, is very important. So that's what I've learned a lot from the work overseas. Yeah.
For me, I'm originally from Ghana, where I did my research, so it wasn't really studying abroad, but just having the practical research part of this work was very beneficial for me, and so I would encourage people to actually go out and do international work, because it kind of opens your eyes to the global world and see what is going on internationally. So it's a very beneficial experience.
Yeah, I mean, having the chance to go to Ethiopia and actually, visit this location that you're working in, doing the research would be completely different if I didn't have this personal connection with, the people who live there, the people who are like managing the system. It affects the way that, first of all, the way that, I understand how things function over there, but also the personal connection with the research that gives you kind of, motivation to do it.
And like I mentioned in my presentation, with the actual study component in Guatemala, I was able to see the differences between what the reports online were saying about the program for fertilizer and the actual what people are getting, what they're receiving, how they perceive that fertilizer, and how they use it. And what we found was starkly different. So if it was just me studying from behind my desk here in Wyoming, I would have never figured that out. So very important aspect there. And then the collaboration between those foreign universities on the work site, the meetings, which Roger and I tried to translate from Spanish to English with several other people there in attendance. That's always a good experience, gets you ready. Working on my Spanish language as a component. And then also, as Ryan was saying, you get to see those affected by your work, and that really gives you fuel to do further study.
Well, thank you. Before I pass the podium back to Gene for some last comments, let's give these guys
I want to add my compliments on the work you guys do. Seems to me that this is just a small microcosm of the excellent kind of work that's going on. And I would highlight that these are students who are contributors to the dialogue in a number of areas. And I would also note that it's their initiative and it's their partnership with their thesis advisors and other faculty that I think really make it possible. So it's that partnership element, it's that collaboration element. I mean, Dale said it great. You said it so well. I mean, it's the partnership not just with who you work with here on campus, it's the partnership with other universities overseas, and and then sharing that back. I mean, the purpose, we had a dinner last night, and one of the discussion point was the role of the land-grant university, which the University of Wyoming is, but we're also the flagship university, and that means really a leader in education, a leader in curriculum, and a leader in research. And it seems to me that, at least I would say, that one of the purposes of this conference has been to demonstrate what people do, demonstrate what it takes to make this kind of work happen, and then to kind of share it. And so I would just say that one of your goals in terms of sharing has already been accomplished. It's been accomplished in the last hour and 15 minutes. So I want to thank you again, and all of the participants for what they've done today. Thank you very much. And a couple of closing thoughts, and let me just say that in about 10 minutes we have a reception starting over here. We have one more session, which is an international poster session, which highlights some faculty work, also some student work, so I invite you to stick around for that. But just some closing thoughts on the role of a Center for Global Studies in the context of this kind of endeavor that these folks are doing. Why do research? Well, you do research to have an impact. You do research to become a part of the dialogue and a contributor to knowledge rather than simply a sponge. Now, I like being a sponge. I like reading the New Yorker and the New York Times on campus. But I really love to see when people like the four individuals to my left are part of the dialogue. And they are part of the dialogue, and that's the role of a university, and that's the role of your university here in Laramie and as the University of Wyoming. Those upfront links that Rob Gottby talked about in terms of his comment was, if he weren't here, was, he found out kind of after the fact that, somebody else was going to Germany for a sabbatical. What's the role of having the links up front? Well, the collaboration between a faculty member and a student, but also across various disciplines, we can actually use a center like the Center for Global Studies or other institutes on campus to really draw those connections together. What will that do? That will enhance the work. It enhances the expertise up front. I think it improves the research questions. I think it does the sorts of next step sorts of things that you guys are talking about. Internationalization and globalization, that's a natural, believe it or not, at the University of Wyoming, given all of the emphasis on this in terms of getting students abroad, bringing international students here. I think the next step is creative activity, more creative activity and research abroad, whether that's in the humanities, the social sciences, or the sciences. Seeing experts working across these various disciplines, again, bringing those expertise, that expertise together. I think we've seen what excellence we've got going on right now. You four are an epitomize that. Just think what we can be. So that's the challenge I'll put out for all of us. First of all of us that are part of this campus community, let's continue to think about what we can do. Let's think about the partnerships that we can have on campus. We'll energize our deans and our department heads and others to see that we continue this work. And the purpose of this launch for the Center of Global Studies is specifically to enhance this kind of collaborative work, collaborative global research, to enhance graduate education and undergraduate research experiences, and internationalization and that outreach piece, which is also part of the land-grant mission. I think this is a model. It's a model that we're seeing on campus with other initiatives, such as the Wyoming Institute for Humanities Research. So let me just say that I wouldn't just plug this institute that I have a passion about. I would plug other efforts as well. It's about bringing, it's not just about sending 20% of the kids abroad. Very good question about what study abroad does. It's about bringing it home for the 80% who aren't going anywhere, but we'll try to get them out there, because getting them out there can be here. So it's not just going out there, that's part of it. Bringing it back here and sharing it here is important. So I guess I'd make a commitment to you that you'll see more conferences like this, that you'll see them in places around Wyoming, that you'll see the impact of this in the broader dialogues on a number of issues. So I'm very pleased by the variety that we've had in the discussion across this whole afternoon and the morning. And I look forward to greater partnerships with all of you. I just want to thank you guys. I want to thank everybody involved. I want to thank the staff and faculty and students of the Global and Area Studies program. In particular, Manuela Hoffer-McIntyre, who's right here, Carlinda A.C., who I wish would walk in, Dave Messenger, who's on the faculty over to my left. Could we thank them in particular, please?